Now consider the case with same load, that is unity power factor load, but different moment. The moment when rotor has rotated by 30 degree in the direction of rotation. In earlier case, we considered the moment when north and south pole axis was lying along this vertical axis. Now, after few second, millisecond or whatever, depending upon the speed, when it has rotated by 30 degree, the moment will be like this. So, we can see that at this moment, the flux linkage to the conductors of phase A is not maximum as in earlier case. There it was maximum, now it is lesser than maximum. But flux linkage with this coil will be more than the previous case. And what about flux linkage to this coil? So, this is 30 degree, so perpendicular to this axis B and B dash axis. It means at this moment no flux is linking with the conductors of phase B, as this axis is lying perpendicular to this axis. So, the corresponding phasor diagram what we wrote, what we made earlier will be shifted. See, earlier we showed EA along vertical axis. Now, it will be, let us make vertical and horizontal axis. This is vertical axis and this is horizontal axis. So, let us draw phasor EA, induced EMF in phase A at this moment, which was represented by EA, rotated 30 degree in the same direction, and its projection on vertical axis will give you instantaneous value of EMF induced in that phase. We have discussed it right in the beginning. What about B? So, B earlier shifted by 30 degree will attain this position EB. You can check it from the previous case phasor diagram. Once this phasor is rotated, this is also rotated, as phase difference between the two EMFs is 120 degrees. So, 90 plus 30 120. And what about phase C? All three phasors are rotated by 30 degree. So, earlier it was making an angle of 60 degree, now it will make an angle of 30 degree with the vertical axis. So, that 90 plus 30 120, or here you can check 30 plus 30 60 plus 120 180, right. Write it EC. So, corresponding instantaneous values may be easily evaluated, as can be observed from this diagram also. What will be EMF induced in phase B? So, this is B dash, and flux, no flux linkage perpendicular to that, right. So, at that time EMF induced in this phase is crossing 0. What about this? This is C dash, and dash is having dot, it means negative polarity of EMF. So, check for C phases. C, upper half is for positive, negative half is for negative. If you want to get magnitude, C EC cosine of 30. Earlier in case 1, also polarity of induced EMF in phase C was negative, but magnitude was lesser, that was 60 degree, and projection of this along vertical axis will be in previous case EC cosine 60, which is lesser than EC cosine 30 now. So, magnitude is increasing towards negative direction. Fine. I think you are started feeling the effect. Okay, fine. So, for this moment when rotor is aligned along this axis, now we are going to check the effect of armature flux on main field flux, whether it is same as in earlier case, that is cross magnetizing or not, just to see this. So, for that start the similar procedure. What was that? First we will write the corresponding phase currents and corresponding fluxes and resultant of armature flux. and compare with the main field flux. So, this time main field flux is having direction this way, whatever it is having. So, for that power factor, unity power factor load, wherever EMF will be there, current will be there in the same phase IA, that is a unity power factor angle is 0. Here IB and here IC, fine. So, first write instantaneous values IA, IB, IC and corresponding fluxes. So, at this moment what will be IA? IM cosine 30. So, right here vertical projection gives instantaneous value, right. IM vertical projection for IA will be IM cosine 30. Cosine 30 means sin 60 root 3 by 2, that is root 3 by 2 IM. This implies corresponding flux in phase A having maximum value as phi m will be phi m root 3 by 2 phi m. Similarly, instantaneous value of IB vertical projection will be 0. This implies at this moment no flux generated by phase B, 0, not going to disturb, as EMF induced is 0 at this moment in phase B, corresponding phase current in phase B is 0. So, flux in phase B is 0, means in phase B somewhere it is at this position. In phase A it is root 3 by 2 something positive, so it will be 1.73 half around somewhere here, right. See, try to visualize the movement of three fluxes. Flux A oscillates here, flux B oscillates here, flux C oscillates here. So, at this moment from the information of these two we can say that at this moment phi A has its position somewhere here, root 3 by 2 times phi m, this is phi m, if phi m magnitude somewhere here. At that time phi B is at center. Let us check for IC. So, at that time IC is having negative sign and projection is IC cosine of IM cosine 30, that is minus IM cos 30 degree, that is minus root 3 by 2 IM. This implies phi C will be minus root 3 by 2 phi m. Try to visualize this. At this moment negative of C will be having this region and magnitude is similar to that, right. So, somewhere at this moment the three fluxes are A is somewhere here, B is here and phi C is somewhere here. So, what will be resultant? Just draw it. So, if you want to draw resultant, so let us have phi A somewhere in this direction, in this axis also, right, because whatever the current in phase A is there, corresponding flux will be along its axis. So, this is root 3 by 2 phi m. Phi B is 0, no need to discuss anymore. Phi C is negative of this, so C, so negative will be somewhere here in this axis. What is angle between these two? 60, right? We have discussed 60, 60, 60, 180, 60, 60, 60, 180, right? So, along this, in between angle is 60 degree. And what is magnitude? Root 3 by 2, same, phi m. So, we have resultant of these two as various ways we can take projections or directly we can find out resultant. Parallelogram law of vector addition. Let us say phi AR, fine. So, how to get phi AR? Phi AR may be written as, what is the formula? Suppose A and B, two vectors are there, A square, magnitude of A square plus B square plus twice of AB cosine angle between them. Just check it, I think. So, A square root 3 by 2 phi m square plus same, just write 2 here, okay, right here, plus b square plus twice of AB root 3 by 2 phi m. This is A. Again B is same. Sometimes it might be different. Just take care. That's why I am not writing a square directly. Cosine of angle between them 60 degree. Just solve it. So this is same. This is same. Again these two will give you a square, and a square will be, okay, just write here, under root, this will be 3 by 4, 3 by 4 phi m square, just take common, 1 plus 1, right. What about this? Cosine 60 is half sine 30, right, so get cancelled with 2, so again it will be 3 by 4 phi m square, that is plus 1. So now we have 3 into 3, come take it outside, phi m square as phi m and 4 as 2, that is coming out to be 1.5 or 3 by 2, same, phi m. What about direction? As these two magnitudes are same, so using the formula or directly you can write half of that. As magnitudes are same, so in between 30 degree. So we can say that our phi AR is making an angle of 30 degree with the horizontal. This is phi AR. What about phi F? So first draw vertical axis also. At this moment phi F is making an angle of 30 degree with the vertical. That's why if you want to represent phi F, so make it along this 30 degree. You can observe from here. Now phi F is not vertical, no longer vertical, 30 degree. So what will be angle between these two? Again we can observe that angle between phi F and phi AR is 90 degree. That is phi AR, resultant armature flux, is again lagging with the main field flux by 90 degree. So in the two cases, previous moment and this moment, we can conclude that. You can check for other cases also. You can just take as your home assignment or like that. I am not asking you to submit it, but for your notebook or notes or practice, take some other moment like 60 degree, 45 degree, 90 degree or whatever you want, wherever you want, just check. You will find that at each case, at each moment, for every case, this is maintained, that is phi AR is lagging with phi F by 90 degree, hence the effect will be cross magnetizing, and you know what does it mean. With the help of wave forms we have discussed it, that its action is opposite in leading half and trailing half. So sometimes helping and sometimes opposing, that is cross magnetizing for case 1 when our load is unity power factor. Hope it is clear to you. Now come to the next case. So far we have discussed case 1, that is unity power factor. Now take any lagging or leading first. So take lagging power factor first. So write here case 2. Purely inductive load, or you may write 90 degree lagging power factor load, right. So for this case, now take the original one. Take the original one. Original case, that is case 1, where we showed our axis of field as vertical. This was the previous case, right? Doesn't matter. right in center. So this, for this case also, or for any other case you may discuss. So this will be cross, right, because we are going to create north and south pole, right. Again you can take some other cases also. Let us discuss the simplest case or any one case. So adopting same procedure for this moment, for such type of load, we will try to find out the instantaneous values of EMFs induced in the three phases of a stator winding. So for phase A, it was maximum, if you remember, it was along vertical axis. Why? We know it very well, as instantaneous value is obtained by taking vertical projection at any moment of time. So at this moment, when alignment of rotor field is along this is having maximum induced EMF, hence the phasor will be along vertical position at this moment. Write the remaining two balanced phasors of voltages. EB and EC. What next? For this 90-degree lagging power factor load, what will be the direction of current? Current lags corresponding phase voltage by 90 degree. We know it very well, right? So if this is EA, so IA will be lagging EA by 90 degree. What about EB? Lagging 90 degrees. So first extend this axis, vertical axis along negative direction, and these two are having phase difference of 120 degree. So 90 degree means 30 degree with this, or 60 degree with this. You may write 60 degree with this. Let's check it. This plus this is 120. No, not 60, 30. Check it. Phase displacement between IA and IB will be 120 degree. Whatever it is coming out to be, just mark it here, right? So this is 90 plus 30, right? 120 degree apart. What about IC? Lagging EC by 120 degree. So mark somewhere IC, right? IC. So this must be 120, so this will be 30 degree. No problem. For this power factor load, 90 degree lagging power factor load, current lags corresponding phase voltages by 90 degree. IA lags EA by 90 degree. IB, this will be B. This is IA. So IB lags EB by 90 degree and IC lags EC by 90 degree. 90 plus 30, 120, right? Fine. Now we will evaluate the instantaneous values IA, IB, IC. So take the instantaneous value by taking vertical projection of IA. So IA vertical projection is 0 at this moment, right? What is vertical projection of this phasor along vertical? Nil, 0. What about IB? So search for IB. So minus IM cosine 30 degree, that is cosine 30 sin 60 root 3 by 2 minus root 3 by 2 IM. This implies phi A is 0 and phi B is minus root 3 by 2 phi M, isn't it? What about IC? IC is Im cosine 30 degree. So this will be cosine 30 again root 3 by 2, root 3 by 2 Im. This implies phi c will be equal to plus root 3 by 2 phi m. Now in order to get resultant, try to visualize this moment phi a. So flux in A is at central position 0, phi b negative direction, where is b? This somewhere here, and phi c positive direction somewhere here, right. So for phi b, no need to write for phi a. So for phi b, this is negative, so towards this, so just along this parallel line along this. And what about phi c? Positive, phi c positive is this, so along this. What are the magnitudes? Same, root 3 by 2 phi m. Here also root 3 by 2 phi m. So resultant you may get no place here. So whatever resultant will be there, that will be phi AR. You can apply vector addition or you can take projections. So horizontal projection will get cancelled by this. See, the angles between these two will be same. What is the angle with vertical? Suppose here vertical is there. So total 30, 30, right? So take either vertical of these two and horizontal will get cancelled. Horizontal will be cosine of 60 degree of this with positive. The same cosine 60 degree with negative will get cancelled. So only vertical position will be there, and downward, that will be downward, and that will be either this square plus twice of this into this cosine of 60 degree under root, or twice of vertical projection of any one, or directly vertical projection of this plus vertical projection of this. So directly it will be twice of root 3 by 2 phi m into what will be angle 30 degree. Cosine 30 means sine 60, root 3 by 2. So 2 will get cancelled with 2, and this will be 3 by 2 phi m. Again magnitude is coming out to be same as earlier, phi m. What about direction? Downward. So we may observe that phi f is having direction in upward at this moment, and armature reaction flux phi AR is having direction downward, 180 degree opposite, phase displacement of 180 degree, 180 degree lagging, even we can say leading, doesn't matter. So 180 degree apart means opposing every time, purely demagnetizing. If you want to realize this effect with the help of waveforms, so draw phi f, right here phi f, and draw phi AR. So phi AR will be phi AR, and you can see at any moment of time for such power factor load, this armature reaction flux is opposing main field flux every time. So this effect is known as purely demagnetizing effect. So for such power factor load, we will conclude that effect of armature reaction is purely demagnetizing. Now consider next, now you can consider another moment also, as in previous case. Now take the moment when this has been rotated by 30 degree or 45 degree or 60 degree, and there also you will see that magnitude of phi AR will be 3 by 2 phi m, and it will be having a phase displacement with phi f by 180 degree. It means at any case, at any moment of time, it is opposing, big enemy of phi f. That's why demagnetizing. Now consider the case 3, that is purely capacitive. Right here, purely capacitive load, that is leading 90-degree leading power factor load. So for leading power factor load, currents will be leading the respective phase EMFs by 90-degree. So just draw it. So again we are taking the same moment when alignment of rotor is like this. We can take any moment, just try to focus on the concept. So at this moment, what will be the alignment of IA leading EA, this is center, IA leading EA by 90-degree. Again, what about B leading EB by 90-degree? Leading, right, 90-degree. And what about C leading EC by 90-degree? Fine. So what about angles? Because we have to take projections along vertical axis in order to get the instantaneous values at this moment, just write IC here. So what will be angle between these two? This is 90, so this will be 30. As currents are also balanced, three phase currents are also balanced, so in between 120-degree phase displacement must be there. What about this angle? This is 90, so this is 30 to get 120. And what about this angle? What about this angle? See, this is 90, so this will be 30. In order to get the phase displacement between IA and IC 120, this is 90, this is horizontal, this is vertical, 90, so this will be 30. So again same procedure. IA, again in this case also IA is 0, you can see no vertical projection. What about IB? So where is IB? IB is having cos 30, IM cos 30 with plus sign. So this will be plus, this will be plus. What about IC? Vertical projection will be IM cosine 30 with negative sign. IM cosine 30, negative sign, hence negative sign here. So if we want to draw the resultant flux, armature flux, so this will be no contribution of flux in phase A. What about flux in phase B? Positive. So positive direction of B is this. So along this, just draw this. What is magnitude? Root 3 by 2 phi m. What about C? Negative. Root 3 by 2, C is this. So negative is this. So negative direction of this is, magnitude is root 3 by 2 phi m. Angle between these two 60, again 60, 60, 60, 60, anyway, right. So this is 60 degree. What about resultant? Either resultant of these two phases using vector addition rule or projection. If you will take projection, so horizontal projection will get cancelled out as these two magnitudes are same. Vertical projection will be, so this will be, this angle will be, resultant will make an angle of 30 degree, right, half of this. So either way you can evaluate. Let us take any one. Let us take projection 1. The horizontal projection will get cancelled. Vertical projection will be this root 3 by 2 phi m cosine of 30 degree, again the same magnitude. So phi AR will have as horizontal is having 0, so vertical only under root square of that will give you twice of root 3 by 2 phi m cosine of 30 degree. Fine. So cosine of 30 degrees root 3 by 2, same this you are getting same, right? You can check it. 2 root 3 by 2 phi m and cosine 30 is root 3 by 2. So 3 by 2 phi m along vertical direction. So what you can observe, phi f is along this vertical and phi AR is also along the direction of main field flux. It's good, it's helping. So you can take another cases also, take 30 degree, 45, 60 and like that. You will see in each case the resultant of armature flux, that is phi AR, is having magnitude of 3 by 2 phi m, and in the same direction alignment will be same as that of the main field flux. It means in this case 90 degree leading power factor load, it is helping the main field flux every moment. So graphically, if this is phi f and you want to show phi AR, so it will be in same phase, right? So helping positive, positive, negative, negative, positive, 0, 0, very good friend. So we have discussed this case also, and this effect is known as magnetizing effect, purely magnetizing effect. So we have discussed the various natures of the same phi AR. Sometimes it is culprit in case of purely lagging, always opposing the main field flux. Sometimes very friendly, very true friend, ready to help at every moment in this case, and in previous case cross magnetizing effect in case of purely resistive load, where sometimes helping, sometimes opposing, helping, opposing, cross magnetizing.